Hey everyone, welcome back. In this video we will connect our application to the MongoDB and talk about repository pattern and abstract repository pattern. But first of all we need to install a few things, and one of them is Docker Desktop, and we also need Docker Compose, and that comes with the Docker Desktop if you're not on Linux, and if you are, you can download the plugin separately from here. I will leave these links to the description. Also, we need a tool to see and visualize our data in MongoDB, and I prefer MongoCompose, but you can use something else like Studio 3T or anything else you want. Okay, I'm a big fan of running databases inside of a Docker container, and I'm going to use Docker Compose, which is a way of running one or more containers at the same time, and we will be using it in the future videos to run multiple microservices and databases all together in the same network. So let me jump in and I'll show you how that works. You need a Docker Compose file, and you want to put this Docker Compose file in the same directory next to where you're running your API. So I'm just going to create a file in the root directory called Docker Compose, and inside of here we're going to define all the stuff we need for our database. And the first thing I'm going to clear is services. Anything inside the services section will be run as a container when you run Docker Compose up. And I will declare Mongo as my service, and this name can be whenever you want, and this will make part of the name of the container when it's running. And I'll show you what it looks like when we run this. In the services section we're going to define all the properties for our container. So first thing I'm going to define is the image we're going to use, and we will be using Mongo. And if you don't give any version to it, you will use the latest stable version for our project, and I believe LTS is 7.0 right now. And if you're going to use this on your own project, please use your required version here. Next, I'm going to name our container, and I'm going to name it market dev, and this is optional. And if you don't give a name to the container, Docker is going to give a random name for our container like mongo-1 or something like that. And next, we want this container to restart always. And after that, we'll define the ports as 2017-017 to 2017-017. This is the default port for MongoDB. This indicates to Docker internally within the container. It should have the database set up on port 2017-017 and also have it accessible outside of Docker on the same port as well. This actually lets us able to access this database that is inside of the Docker container. And next, we'll define the environment variables, and the only one we need is for the database name, and it's mongo_init database, and the value for it is going to be market dev. And we need to define the volume that we want to use. Why we need volume? If you delete this container, all of the data inside of it will be deleted. In order for that data to persist, we just need to add a volume. And volume is just a way of saying put the data in our local computer but let Docker have access to it. And volumes have to be set up in a very special way. I'm going to actually set the volume up first, then I'm going to tell this image how to use it. So I'm going to go back to the top level and I'll say volumes. Then you give your volume a name. You call it mongo_data. That's all we have to do to declare the volume. And I'm going to tell our image how to use it. So I'll go back up after environment and you say volumes and a dash. Then you give it the name that you use. So this name has to match this name. So it's mongo_data. Then you give it the path that is supposed to map to inside your container, which is data/db. This data/db folder is in the Docker documentation for Mongo. I'll put the link for documentation in the description so you guys can check it out if you want to learn more about it. And that's it. That's our Docker Compose file. And in order to run this Docker Compose file, we need to be in the same exact folder of where the file is. And now all we have to say is Docker Compose up. And that's it. This will run that. And I'm going to also add -d just for detach mode so it doesn't lock up my terminal. So I'll run that, and this might take a while if you don't have the image and if you didn't download it before. But But come back after it's finished. And now I'm going to switch over to the Docker desktop, and I'm going to show you just a couple of small things. This container is called market server, and the reason it has this name because market service is the name of the folder in where I ran that docker compose app command from, because docker compose can run multiple images. For example, if I included our market service API to the docker compose as a service that was connecting this database, I could run my MongoDB container and the API container from the same docker compose file. So if you expand market server, you'll see inside of it is our database that is running, and it's been set up for 2 minutes. It also does similar thing for volumes. If I go over to volumes, you'll see here market server underscore mongo underscore data, and it's going to prepend the folder name to your volume name. And I think those are the main things that you need to know in order to run a database on your computer using Docker. Okay, let's connect our API to this database now. First of all, you need to install FTP packages, and those are Mongoose itself and NestJS/Mongoose. And this might take a while, so I'm going to fast forward this part. After the installation, we go to the app module file and head over to the imports array. We need to add Mongoose module for root here to the imports array, which accepts a database connection URI string where our Mongo database is located. And we're going to use a standard MongoDB URI here. So it's MongoDB localhost, and the port we set up in our Docker compose file is 2017/017 and followed by a slash, and our MongoDB database name, which is market dev. And let's see if we connect to it. Let's go to our terminal and write npm run start :dev. And okay, we see Mongoose dependency is initialized, and we have successfully established a connection to our Docker Mongo database. After we connect our API to the database, first thing we need to define a schema. And a schema in MongoDB maps to a collection and defines the shape of the documents within that collection. In NestJS, we can use decorators to create schemas. So let's head over to our mocked product entity. And first let's add schema on top, import from NestJS Mongoose. This schema decorator maps our product class to our MongoDB collection of the same name, but we have an additional S at the end. So the final MongoDB collection is going to be products. Mongo automatically makes all collections plural and lowercase by default, so keep that in mind when you're naming your schema classes. You can also override this behavior by passing an object in the schema decorator, like there is an object and collection, give the name, whatever you want. Okay, with that setup, now we can start defining properties of product schema. To define properties, all you need to use is prop decorator. But before we dive into this new decorator, let's take a quick step back. You can actually move the ID property from the class entirely. That's because Mongo automatically adds underscore ID property to every schema by default. This actually aligns with the best practices, so it's a win-win. With the ID property out of the way, let's move on to decorating the remaining properties. Name, price, and tags. Now tags is a bit special. NestJS can't automatically reflect the type we need for an array of strings. We need the prop decorator. To fix that, we'll simply pass an array with the type string inside of this decorator, and don't forget to import the prop from NestJS Mongoose package. This array tells Mongoose that tags an array specifically of strings. Okay, after we crafted our product schema definition, we can translate it into a functional Mongoose schema. Imagine this schema is the blueprint for our product data within the Mongo database. So let's create a constant value to hold this schema and name it product schema. And to create this schema, we'll utilize the schema factory that create for class function provided by the Mongoose, and this function takes the product schema definition as an input and generates the corresponding Mongoose schema for us. And we need to export this constant. And one final step to ensure our schema interacts seamlessly with Mongoose functionalities, we need to leverage the hydrated document class from the Mongoose package. So we write export type product document hydrated document, and that takes the product, and that's all. Now that we have the product schema defined, it's time to connect the dots and make it accessible within our application. And remember how we structured our application within the modularity in mind. Here's where it really shines. Since we're working with the product schema within the dedicated product module, we need to inform Mongoose about its existence inside of this child module. So let's navigate to our products module, add an imports array, and within this array we'll introduce the Mongoose module for feature function. This function serves as the bridge between Mongoose and our product schema, and think of Mongoose module for feature as the handshake that establishes communications. And to complete the handshake, we'll need to provide an array containing an object. This object has two key properties. One of them is name, and the name will use the access to module associated with our schema. In our case, it's product.name. Product.name is just a way to get the function name from a JavaScript class, which in this case will give us the string of product. And schema points to the actual schema we crafted. We can access it using product schema, the constant value we defined and exported earlier. The schema will be used to compile this module. And also don't forget to import the product entity. As you might recall, we previously used Mongoose module for root in our main application module. It's important to understand the distinction between these two functions. For root is only used once, typically within the main application module. Its purpose is to establish the global connection to the MongoDB, and for feature is used within the child module, like our products module. It allows us to register specific schemas and modules relevant to the particular module. Okay, now we've successfully registered our product schema within the product module. We can now start using this module. But first, let's clarify the concept of module in Mongoose. An instance of a module is called document. In SQL terms, you can think of documents as rows in a table. Mongoose's module class acts as an abstraction over our data source, provides various methods to interact within these documents. And when we register a new module, such as product, NestJS automatically generates this module class. We can then use this module by injecting it to our service class. So let's do that. In our product service, let's create a constructor, and we have a decorator that is inject module, and that takes a product name. Also, let's create a variable, private read only, product module. This also takes the product. And let's don't forget to import these. After injecting it, let's use it. And there was our mocked product entity before, and this ID is mad because our schema doesn't have this field. And let's remove this. And also we need to turn this IDs to string again, because MongoDB keeps IDs underscore IDs as string. And also we have this, and let's go to the controller file and change this IDs to string as well. And this one, and I think that's all. Let's go back to services. We need to make these functions async now, and we can write to get products like product module.find. And this approach, injecting the module directly into the service, is a straightforward and efficient approach. And this method's simple and avoids adding extra layers between your service and the module. However, this approach does come with some trade-offs. It tightly couples your service and the Mongoose module, making it harder to modify the underlying data access logic without altering the service. Additionally, if you need to use the same database operations within multiple services, you might end up duplicating logic, but this can be quite sufficient for smaller projects or prototypes where simplicity is the key. On the other hand, we can use something called repository pattern. Using this pattern, introduce an additional layer of abstraction that separates database logic from business logic. This approach adheres to the single responsibility principle and makes your codebase easier to maintain and test. By centralizing data access logic in repositories, you can reuse these operations across multiple services, reducing code duplication. This pattern also facilitates feature changes such as swapping out mongoose for another data access layer like TypeORM or Prisma, as the repository abstracts away the specifics of database interaction. However, this added layer introduces complexity, which may not be necessary for smaller projects. So let's create a new file and call it products.repository. And like products, if we have another module in the feature, we will follow the same pattern there as well. Inside of the repository, this is going to be an injectable class because we're going to need to provide some dependencies, and we'll export the class and call it products repository. And we need a constructor here, and inside the constructor we use the inject module decorator to inject the mongoose module. We provide the name of the schema class and this product.name, and we define a private variable here as read only and name it product module, and the type of module product document. The product document type should be what you exported from your schema file as hydrated document, and don't forget to import these. Okay, with this setup, the file contains everything necessary to interact with your product data. By default, NestJS will automatically manage and create a collection based on the provided schema. For instance, if you define a schema with the name of the product, NestJS will create a collection named products in MongoDB. So let's proceed by adding some methods to our product repository to handle operations such as retrieving, creating, updating, and deleting product data. So let's implement the first method in our repository to retrieve a single document from the database. We'll name this find1, and this method will accept a product filter query, which will be type of filter query product document. This type represents a subset of properties of a product, and it will be used to filter the product we want to retrieve. And we're going to return the promise here with the type of product document. And now we just return this product module find1, and we're going to pass in the product filter query. And that's all we have to do to be able to provide an interface for the products collection only, and to be able to return data from it. Next, let's implement a method to retrieve multiple documents from database. This method will be similar to the find one, but we'll return an array of products instead of a single product. We'll name this method find, and it will also accept a product filter query, which will be type of filter query product document. This filter query allows us to specify the criteria for viewing multiple documents. And this method will return a promise again, but this time with product document array, and we can just return this product module find product filter query. Okay, we'll create another one to handle the creation of a product, and this method we will name create, and this will accept a parameter. We can call it create product data. Type of this will be partial product document, because the fact that not all the properties are required for creation. And this will return a promise again with the product document type. And inside of this method we're going to create a new product. So let's make it like new. This product module, and we'll pass the create product data inside of here, and we will return product.save. Okay, let's add another method to update an existing product, and that's going to be find1 and update. So this method will take two parameters, and one of them is going to be a product filter query again. the type of product document, and the other one is going to be update product data. This is going to be a partial product document which contains the new values for the product, and this will return a promise product document type. So we will return this product module, find one and update. We will pass product filter query and update product data. Also we will add a new parameter here that says new true, and this means we want this find when update method to return the updated document. And this find when an update method will allow us to update any or all properties of the product without needing to provide an entire document. That's one advantage of using MongoDB. And let's implement a method to delete a document. We'll call it delete1, and this is going to take a product filter query again, we type filter query product document, and this is going to return a promise with type boolean. And that product filter query is a filter object that helps identify which product to remove from our database. And we can declare a constant here and name it delete result, and we will call this product module delete1 with the product filter query. So this delete1 method will return an acknowledgement and a deleted count. If a document deleted from our database, it will return 1. So I will return delete result dot deleted count equal 1. If it's equal 1, this will return true. If it's not equal 1, if it's 0, then this will return false, indicating there is no document to delete. After we wrote all of these methods, now let's go and add this products repository to providers array of the products module. So I will add products repository here, and now we can use this products repository in products service. So I will go to product service and remove this line from here, and I'll write private read-only products repository, and its type is going to be products repository. And now we can use this products repository in product service, and we can use it for get products, like return this products repository dot find, and I can pass an empty object here for just right now. And we just need to write all of the other methods to be able to use the products repository. I'll just write them and fast forward here. Okay, I just wrote them in. For get products by ID, we use to find one method in products repository. For create product, we use to create, and then for update product, we passed in 2 parameters. One of them is _ID, another one is the update query, and the $set with update product DTO. And the remove product, we call the delete1 function. We send it an ID as _ID. And we can now start our application, though it's already on, and we can test the endpoints. So, but first of all, let's go to Compass first. Let's connect to market dev database on our local. We can see our collection and products collection here, and it's empty for now. So let's go to Postman, and let's make a GET request first. We see empty array because we don't have documents yet. So let's make a POST request with this data and send this POST request, and the document is created with this ID. So if you go to Compass and send a find, we can see our document here. So let's send a GET request again for /products endpoint, and we get an array with that product. So let's send a few more POST requests and send a GET request again, and we see all of the products here. And let's copy this ID and send the GET request to the product/ID endpoint, and we see that document. So let's send a patch request to remove this waterproof string from the tags array. We send it, and we see that we get the tags. So let's send the GET request to this product again. We can see that. So let's send the delete request to /ID. We get a true back. So finally, let's send another GET request to get all products from our database, 3 products. And we go to Compass, and we can see we have 3 products in our database. So everything works perfect. In this repository, we've encapsulated all database operations related to the product module. This makes our product service cleaner and more focused on business logic, while the repository handles data interaction. By using this approach, we not only allow best practices but also prepare our code base for feature scalability and maintainability, but still there is room for improvements. So let's say we have another module here like products, and we want to write another repository file for the same core create, update, delete operations. That will be code duplication, right? So how can we avoid from that? We can create an abstract base repository class and extend it in every repository file in our application, and that way we won't have to rewrite these methods again and again in the future. So let's do that. So I'm going to go to source directory and create a folder and name it database, and I'm going to create a new file inside of it and call it base.repository. And inside of this file we are going to create an abstract class. So this base repository is going to be an injectable class. We'll create and export an abstract class called base repository, and this is going to be a generic type of TypeScript, and this type is extending the document type. We need a constructor in here, so there's going to be a protected read-only constant, and we're going to name it module, and this module generic module that extends this class. So let's write the methods we will use. Let's start with find one. This is going to be an async method, and this will accept a parameter, and let's call it entity filter query. The type of filter query, and we will use the TypeScript generic type here, and this will return a promise with the type T, and this might also return null if there is no matching document. So let's declare a constant called document, and this will return find one, the entity query filter, and execute this. If there is no document, we'll throw not found exception, a document not found with this ID. If there's a document, we return the document. Let's proceed with the next one. Let's write the find method, and this will also accept enter query with type of query with the TypeScript generic type, and this will return promise TypeScript generic type with an array. Return this module find with a query, and there's an extra parenthesis here. Let's delete that one. And let's proceed with the create method, and this will take one parameter, and this is create entity data, and this is going to be a partial type T, and this will return a promise type T, and we're going to create an entity with this new module create entity data, and we will need to return this like this. We first need to save this and cast it as T. Without the stcast, TypeScript struggles to guarantee the return value from the entity.save perfectly matches the generic type T. It knows it's a document that extends T, but there might be a mismatch in properties or methods. Adding stcast explicitly tells the compiler to treat the return value as the specific type T of the repository. This bridges the gap between the generic document type and the concrete entity type. So let's continue with the find when and update method. I'm going to find when and update, and this is going to be taking two parameters, and one of them is going to be filter query with the type filter query type T, and update entity data with the type of update query, but this will be partial T because find when and update method can update some of the fields of the document, so we'll use the partial generic type here, and this method is going to be returning a promise with type T or null. If you don't have the data in our database, we will return this dot module this find when and update, and there will be the query as the first parameter and update into data is the second parameter, and we'll pass in new true to get an updated data from the database, and we will execute this query. And let's not forget to execute these as well. For the last one, we need to write the delete one, and this will also get the filter query to specify what document to delete, and also the generic type, and this is going to return a promise with type boolean again, like we wrote in products repository file. So the same thing, the delete result will be returning from the delete one function. So don't forget to execute it and return delete result, deleted count. If it equals to 1, 2, if not equals to 1, return false. Okay, now we need to use this base repository from the products repository, and I don't know why this is still mad. So let's cast it as hydrated document with type T, and it's not mad anymore. So let's go to products repository and let's extend this base repository from this class, and let's pass in product document, and after that we need to add a super to this class with the product module, and that's it. We don't need any of these methods anymore, so I'll just comment them out. And why is this mad? I forgot to import document from the Mongoose, and it's all good now. So let's try to use the Postman again and see if everything works. So let's make a GET request first, and we have the document, and let's make a POST request again, and we created a new document. If we make a GET request again, got 4 documents right now. So looks like everything working. If we check our database, we have everything. So this base repository is going to be saving us a lot of time in the future, and if you have another modules in the future, we don't have to write these common and core methods again and again and again. We can just extend this base repository from the modules repository and use them. And we can also override these methods. For example, we have a find one method here, and that throws an exception. And if you go to Postman again, let's delete this document and send the GET request to this document again. We get a document not found with ID, with not found error. So if you go to our code again, and let's uncomment this function, and this doesn't throw an not found error. And if you go to Postman again and send the request again, and we get nothing. So we can override these functions if we need to do something specific for our domain. And if we don't, we can use this core functions, core methods from the base repository, and this is going to be all of our repository methods, just like that. And we can get rid of this filter query here. That's it for this video. I hope this will be helpful for you guys. So all of the codes will be in GitHub, and I will open a new branch and push it to there. So just check out the branches, and you can see video by video, and I'll see you guys on the next one.